So 42. Find the values of A and B that make F continuous everywhere. Never? You're talking about me or you're talking about something else? So it's that if X is less than 2, and then it is this. Oops. Between 2 and 3. All right, ready? Okay, so for it to be continuous at 2, what has to be true about the value of this function and the value of this function? They have to be the same. Okay, well, what's the value of this function at x equals 2? How do you know 4-ish? How do you know?
Can't divide by 0.
You can't what? We can't divide by 0. So this has a discontinuity right here at 2, right? Okay. So what are we going to do with that? Well, can we though? Because did I write? Oh yeah, we can factor. Okay. So the top. I see where you're going with that. So this discontinuity is a removable discontinuity. It's just a little hole. It's not an infinite one. What does x squared minus 4 factor into? X plus 2, x minus 2. Thank you for that. So now, cancel them out. And so this one would be, we want it to equal 4, right? So you can fill that hole as long as that equals 4. So what does this have to equal at x equals 2? How do we get 4? Flip the 2 into what was left. Okay, so that was that thing we talked about when you're trying to find the limit. You can't plug a number in directly. First thing, try factor and cancel, and then plug it in. Okay. All right, so now I'm going to plug 2 into here, and when I do that, I get 4a minus 2b plus 3, and what do I need that to equal for this to work? 4, because the value of this function at 2 has to equal the value of this function at 2 for them to be continuous, for the graphs to meet. Yeah.
Well, you have one that's greater than, one that's less than.
Oh, I see what you're saying. So they're both less than. Huh. Yeah, that is weird. You would have thought that one of those would be, because you'll still have 2 holes that are on top of each other, so they'd still be 2 holes. Yeah, that is strange. So one of those, it seems like, you see what he's saying? One of those, it seems like, should be, yeah. We'll just throw that in there. We won't tell anybody. Okay. Yeah, because you're right. Because if they both have holes there, even if you put the 2 holes on top of each other, there's still a hole there, so it's still be discontinuous.
Basically,
You have to make them meet, yeah. Okay, so we're making the graphs meet at x equals 2, and then we're also going to make the graphs meet at x equals 3. Okay, so what does this one equal when I plug 3 in? What does this equal?
9a.
Okay, 9a
3b.
plus 3, and we need that to equal what this function equals when I plug 3 in, which would be 6 minus a plus b. So 2 equations, 2 variables, we're off and running. How do you want to solve that system of equations? Okay, we clean this up a little bit first. How do you want to mess with that?
Add an A. 6.
Okay, so let's get all the A's and the B's on the left and all the numbers on the right. Okay, so if I add A to both sides, that'll give me 10A because I'm adding. Okay, if I subtract B from there, then that is minus 4B, and then subtract the 3 over there, so that equals 3. So far, so good. Okay, and then I'm going to do the same thing up here. I'm just going to scoop this 3 over there and make that equal to 1 instead. So 4a minus 2b equals 1. So now what do you want to do? Okay. Thanks for that comment. What's the easiest way probably to solve this? We could use a matrix. That'd be exciting. We could graph them. I know you love to do that. Substitution or elimination, which one? Elimination, so if I take this one and multiply by what?
-2.
-2. So that'll give me -8a plus 4b equals -34. So ignore that one for right now. 10a, take away 8a is 2a.
34.
What did I do wrong? How did I get -34?
It looks like 17.
Oh, that's like a 17, but it's a parenthesis. Great minds think alike. Zach knows what's up. So that should be -2. Sorry, so the b's cancel. 3, take away 2 is 1. So a equals 1/2. This is nice and neat work there, easy to follow. Plug it back in. So if I plug it in there, that will be 5. Subtract 5 from both sides is -2. -2 divided by -4 is 1/2. So a is 1/2. B is 1/2. And it's an even problem, so you guys can't check the back of the book and tell me if I'm right or not. Would be good. Okay? So yeah, this issue here, I don't know if that was a typo. Because yeah, you're right. You would need one of them to be equal to that. Okay, and then you said 43 also? Okay, 43. Which of the following functions f has a removable discontinuity at a? If the discontinuity is removable, find a function of g. Okay, so then we just have to fix it. So the first one is x to the 4th minus 1 over x minus 1. And we're looking at, of course, a equals 1. Can I plug 1 directly in? Nope. So what's my first strategy? Factor. What does the top factor into? Oh, it's deceptively simple. X squared minus 1, x squared plus 1. It's still the difference of 2 squares. Because x to the 4th is x squared, so you can factor it like that. Okay? So can I cancel now? Nope. So what do I have to do? Factor again. So I'm going to take the x squared minus 1 and factor it into x plus 1 times x minus 1. Like that. What? Speak, Shannon. Speak. Yes. What do I do with that? Cancel. Okay. And then that allows me now, since I canceled the thing on the bottom, to plug in 1 for x. And so that gives me 2 times 2, which is 4. All right. And so if you want to get technical here, that's a removable discontinuity. We removed it when we canceled. So we want to find a new function g. So here's what they really want us to write, is that g of x equals the original thing, x to the 4th minus 1 over x minus 1 when x does not equal 1. And then what did we figure out it has to equal when x equals 1? So that is our newly defined function that is now continuous at a. Oh, so now you're going to call me on that.
Yeah.
All right. Okay, but thanks for being that guy. Got to have someone to be that guy. All right, B, let's take a look at f of x equals x cubed minus x squared minus 2x over x minus 2. And we're looking at a equals 2. I'm going to let you do C.
Really?
No. It's a greatest integer value function with
Oh.
a trig function inside.
Oh, wow.
Don't know how that's going to work out for us. Okay, so you can't plug in 2. So what do? Factor. What can I factor? How can I factor? Take an x out of every term. So that gives me that. Now what? Factor again. What does that factor into? X minus 2, x plus 1. And then these will cancel, right? And so now to make Matthew happy, we'll rewrite our new function like they did apparently in the back of the book. So g of x equals this function here, x squared plus x, as long as x does not equal 2, right? Oh, you don't have to write it because we removed it, I assume.
You don't have to write the whole.
Okay, so what do they have as their answer?
G of x equals x squared.
That's it. Oh, so all they want is, oh, okay. All right, well, that's even easier then. So we don't have to plug the 2 in there and fill the hole or anything, we just cancel them and done. Okay, that works for me.
You don't have to.
We don't have to do it?
It's not.
Why?
Have it right.
Oh, okay, well, they don't have it back there? That's because it's not a removable discontinuity. Let's look at the graph of C. I've never done a tree function in there. So now to find the greatest integer. It's in there somewhere. Maybe not. Is it the integer part? Let's try that. Let's just do it in there. Okay, yeah, so there's the step function, right? Okay, but they want us to do not that, but they want us to put the sine of x in there. Oh, too many things. Way too much. Got excited. Cross fingers. Oh. Whoa.
It's easier how that.
Why would that not?
I think they should all round.
Oh, is it all 0? Yeah, because sine is never bigger than 1, so they all round to 0. Okay, so if I change this to, let's turn off the axes and then look at the graph. Okay, so the graph is just a straight line there at x equals 0 because the value of sine bounces in between -1 and 1, right? So every answer that it gets, since we're always rounding down, it's going to take and round it to what? 0, except at where? What answers would not get rounded down to 0? Yeah, 1 and -1. What would they get rounded to? What would you round if you did, the sine of pi over 2 and you got 1 as an answer and then you round that down to the nearest whole number? What are you going to get as an answer? You're going to get 1, right? So the graph, the calculator can't show it because its resolution isn't good enough, and I guess this isn't a good thing to do either because it's a trigonometric thing, but it's going to have a line at 0 and then technically an infinitely small dot at 1. And then a line at 0, so there's a little tiny hole there, and then a hole there and a dot at -1, and then a hole here and a dot at 1, right? Doesn't that seem like that the calculator doesn't have the ability to show these individual points? So there's going to be a hole in this graph at every pi over 2, 3 pi over 2, 5 pi over 2, and so forth, where you get -1 and 1 as an answer. So we can't rewrite that function to make it continuous because there's an infinite number of discontinuity there, so that's why the answer is not that. Does that make sense? What's that? And fill it that way? I guess so. Okay, maybe so. Well, no, because they want it at pi. The sign of pi is just 0, right? So that should just be 0. So So which of the following functions has a removable discontinuity at A? So I guess if they're asking specifically at x equals pi, that's not a removable discontinuity, so then they just stop. Oh, okay. That's a weird one. I've never looked at that one before. That's fun, yeah. Okay, anything else?
Yeah. 47, 48,
Go.
49, 50.
Okay, you're gonna be mad about these because they're ridiculously easy. Matt, you got them and you weren't even here?
Oh, 47.
Okay, use the intermediate value theorem to show that there is a root of the given equation in the specified interval. So you only have to do two things. First of all, set it equal to 0, which this already is. Okay, now plug in 1. What do you get when you plug in 1? 1 plus 1 minus 3, which is -1. What do you get when you plug in 2? 15. Okay, so since this is negative and this is positive, that means somewhere in between those two numbers, since this is a polynomial continuous function, has to cross through the x-axis, and so it has a root in there. Okay, that's all you have to do. The function's continuous. Negative value, positive value, so somewhere in between it must be 0. So for 48, if you have the cube root of x equals 1 minus x, to start with, if we're finding roots, you have to set it equal to 0 before we plug things in. So I have to take this and change it into root x plus x minus 1 equals 0. And then this is in between 0 and 1. So if you plug 0 in there, what do you get? -1. If you plug 1 in there, what do you get? 1. And 1 plus 1 minus 1 is 1. So again, same thing. This is negative, this is positive, so somewhere in between 0 and 1, it must be 0. Assuming this is a continuous function, and we know this is a continuous function because it's made up of a root function and polynomial. Okay? And so you can do the same thing. I'll let you finish these on your own with 49 and 50. Just set them equal to 0, plug in the values. One of them should come out to be negative, one of them should come out to be positive. All right?
That's 5.
That's 5. Okay. The ship is righting itself.
The only one I can find is Jake, dude.
Okay, anything else? No? You're good? Okay, so finish up 49 and 50 on your own if you need to still.
49.
And then turn those in.
Mr. Rosen, about 50.
They're saying doing 0 doesn't work because f of 0 is 0. So we need to find a different number in this interval where when you plug it in you get a negative answer. Okay? So basically you could just do at this point a guess and check. You could say f of 0 is 0, so that's not going to work. Try f of something else. Well, let's not guess the right answer right away. Let's try f of 0.5 just for funnies. Okay? So I'm still inside this interval, so it's okay. What do you get if you plug 0.5 in there? Do you get a negative for it? Okay, negative what? Oh yeah, we believe you. What did you get? Negative what? Okay, negative 0.453-ish. So you could have done that. So you, what's that? Yeah, so 0.5 works also. Okay, so what we're saying here is since 0.5 is negative and 1.4 is positive, then that means it has to cross the x-axis somewhere in between 0.5 and 1.4, right? Well, if it crosses the x-axis somewhere in between 0.5 and 1.4, does it not also cross the x-axis somewhere in between 0 and 1.4? So you see how that works? So we just narrowed the interval so it's still okay. So if you could not find a number inside here that was negative, then you'd be in trouble. But we did. Apparently there's lots of them. Okay? So we can't use 0. We need to find one that does come out to be negative. All right?
Yeah, you do. It's your turn to do it.
Four days.
Justin's every once.